Hi everyone, welcome to RS Tech Media channel. Today I am going to explain about AC and DC transmission. Uh, the main agenda of this topic is so many students, beginners, and also the professional engineers who are not in electronics field. They're having the doubt that so many products what we are using in the day-to-day life, like phones, are so many uh, so many products we are using that products are using DC, but still that our home and offices is getting the AC lines as input. So why not DC? This is what everyone having the doubt. So that with some little explanation, I am going to clear those doubts. So welcome. We'll start topic. DC transmission. First thing, DC transmission. Um, with one simple circuit, I'm going to explain. You can see here voltage we are feeding and wires we connected to the resistor. Now, this is what our circuit what we have connected, but within that circuit, some more resistance also present. That is what I am showing in the practical circuit. I mentioned as RS as source resistance and RL as line resistance. Meaning with the source whatever we connected with the battery has its own source resistance, and also whatever we connected with the wire also having the resistance. So um, because of these resistances also present in the circuit, at the B and C point we are not getting same as voltage what we are feeding, because of voltage drop, some voltage drop will occur in the RS and some voltage drop will occur in the Y. Then the remaining voltage will come at the output point, means B and C point. So you can see the formula at the resistor R. In ideal circuit we are getting same as input voltage, but at the resistor R in practical circuit we are getting VR, some VR is equal to V minus Vs, means source voltage in the sense I am going to tell whatever source resistance is having, that source resistance will also have some voltage drop, that is what Vs, minus line resistance. In the line what we connected, that wire also having the resistance, because of that resistance some voltage drop will occur in the wire. So everything we subtract from the voltage, so remaining voltage only will come at the output point B and C. This is what the simple circuit. But think that I want to tell you one thing. uh, Whenever that wire is having the resistance, if that is very simple, small length, then no issues, that resistance will is very less. So you are not able to think, you are not able to see any voltage drop at B and C. But if wire length is very lengthier, if wire length is keep on increases, then resistance of the wire also will keep on increases. This is one thing. So when the power generated to your home or some long distances it will go, the because of wires are very lengthier, volt lot of power dissipation will happen in the wires only, so that we are not able to get the enough power at the output, means at the load side. So this is what the one thing. If wire length is increases, resistance increases, so that long distances DC transmission is very difficult. Even though if we do also, we are not able to get the enough power at the output. So this is what one thing. Next, in the DC we are not able to boost or step up the voltage or voltages, like we are feeding 5 voltage at here, and getting 10 voltage is very difficult, and it has lot of complicated circuits. So that is what second point. And also we are not able to increase, also not able to decrease also, from input to output in the DC lines. So this is why DC transmission we are not, DC transmission is not at all using. This is what. one thing. Now, this how it will be good in the AC transmission. That is what I'm going to explain now. Now, coming to AC transmission, you can see here I am showing simple transformer. We are feeding VP means voltage at the primary side, and VS means voltage at the secondary side. So NP means windings at the primary side, NS means winding at the secondary side. So now, mm, if winding simple working functionality I will tell, when AC voltages is applied at the primary side, because of AC, that windings acts as an inductor and it will generate the magnetic field. Due to those magnetic field at the secondary side also, magnetic field will be impacting at the secondary windings, so that when the secondary windings are more, then more voltage than the VP means primary winding side voltage, more than that, because of more windings are there, secondary voltage will be more. This is what step up we can I can tell. So now at the primary side we are feeding some voltages, but the secondary side winding is very less compared to windings at primary side. Then step down means voltage will reduce at the secondary side, and we are getting step down means less voltage compared to VP. This is what transformer functionality. So coming to here, this is what the equation VP by VS is equal to NP by NS. uh, Simple. If we go to, if we want to voltage at the secondary side, simple is, if NS is increases means secondary winding size increases, voltage at the secondary side also it will increase. It is, both windings are not at all connected, but because of magnetic field it is increasing. This is what the functionality of transformer. So that because of AC, because of AC voltages, it will generate the magnetic field, so that because of the secondary windings we are getting the more or less, whatever we can configure, that voltage we are stepping up as step down, step up, both we can use, and we can get the secondary voltage with the transformer. This is the simple way to get the, to boost, to step up or step down the voltage. But in the DC it is very difficult, lot of complex circuit is needed. So that from the power generator to homes or offices or still more longer distances, they are using in between transformers, big transformers, so that voltage they can step up also, and at the end point to the homes or in the villages, in the cities, they can step down also. This is what the concept of AC transmission line. So that you can see in the next slide, power generated to consumer line, you can see at the power plant we are generating just 12 kilovolt, but because of step up transformer we are generating 400 kilovolt. Then again at the coming to consumer lines we are stepping down to 13 kilovolt, and again to the homes or offices we are again convert step down to 240 volts. So like this, for the longer distances, even the longer wires we are still having, that is also having, that wires also having resistances, even the voltage drop occurs also because of this AC lines. If we fix the transformer, then it can again step up the voltage. This is what the use of transformer, so that AC lines without lot of losses, we can get the enough voltage at the consumer point. So this is why we are uh, getting the AC line as an input, not DC. So again, from the 240 volts AC we can convert to DC for mobile chargers or our systems, laptops, everything. So this is what today's topic. I hope everyone can able to understand now why DC transmission lines are not using, and why AC transmission lines is very needed, very useful, and that is implemented. So thank you for watching this video, and please subscribe, like and share for more videos and support me. Thank you.